Welcome to this presentation. We will go through the journey of the fascinating world of AI. We will explore AI from a human perspective by making complex concepts accessible. I am Angelica, your presenter for today. This presentation aims to give you a solid foundation in AI concepts, so you don't require any technical background to attend this presentation and follow through. In no particular order, this is what we will cover in today's session. We will look at understanding artificial intelligence from a very fundamental point of view. We will also look at how generative AI is different from traditional AI and different facets of AI. We will then jump on to looking at AI's impact on society and why human-centric approach matters in the AI development that we are seeing. We will look at EU's approach to human-centric AI after that, and the rules and regulations around it, and how EU has led the way in developing ethical and responsible AI through some real-world applications. At the end of this presentation, we will look at how the future may look like, some trends, some recommendations that we should be considering to develop a human-centric world with AI. And we will look at how to build trust in the age of AI through some key takeaways. Before we go further into this presentation, let's form an understanding of what AI really is. For something to be considered as AI, it needs to have three important things. The first thing is it needs to be a system that will mimic human intelligence. It needs to think like you and I, and it needs to be able to perform tasks that typically require the way we think. The second thing is it needs to be based on both algorithms and data, because it learns from patterns from a vast amount of data that we provided. And the third thing is that it is built to design specific problems, not problems at large. Because most AI today that has been in practice, they specialize in a particular task. Since we looked at what AI is, now let's look at where it all began. The field officially began in 1950s, and the term was coined by John McCarthy in Dartmouth College when he was proposing at a workshop. Early work focused on problem solving and symbolic methods, leading to problems like logic theorists and early game playing chess. Between 1956 and 1970s, a lot of progress was made in demonstrating what AI can do in limited domains, such as algebra word problems. But the problem was computational limits, and it was not easy to scale AI, which became really obvious between mid-70s and early 80s because the promises were not fulfilled and the computational power was not enough for these complex problems to show its worth. Then in 1980s, AI found some commercial success through expert systems, which are programs designed to emulate the decision-making ability of a human expert in a very narrow domain, such as medical diagnosis. This led to some renewed optimism and investment. But expert systems proved costly to maintain and difficult to scale, which is why we started having another AI winter. Then between 1990s and 2000s, AI shifted more towards mathematical and statistical approaches, which we now know as machine learning, which gained a lot of traction between that period by focusing on systems learning from data rather than being explicitly programmed with rules. A major public success was IBM's Deep Blue defeating Garry Kasparov in chess in 1997, and the internet started providing vast amounts of data. Then between 2010s till now, what we see is AI explosion, which has been fueled by big data, powerful GPUs, and a lot of algorithmic breakthroughs. Deep learning, which is a subset of ML, which is machine learning, which uses layered neural networks, achieved remarkable success starting around 2012. This led to breakthroughs in computer vision, natural language processing, speech recognition, and a lot more. Generative AI then became the next big thing, which is extremely capable of creating new contents and creates its own patterns. It has been emerging as a major force in how we use AI today. There are different ways to think about AI if you want to categorize them. This is one way to look at it. There is narrow AI, which is AI that is designed for specific tasks. And if you use this AI for a task it's not designed on, it may not perform so well. Most of the AI today falls under this category. And on the other hand, there's general AI, and this kind of AI performs on a human level intelligence across all domains, not just one or two domains. They can reason and plan and solve problems, and they have agency. They can demonstrate human consciousness. There is a consensus among AI researchers that this kind of AI is decades away. While there is debate about the exact timelines, no AGI has yet been realized, and most experts agree it remains a long-term goal. Some researchers argue that AGI could exhibit human-level performance without subjective experience or self-awareness, while others believe consciousness is a necessary component of true AGI. Here is another way to look into AI. There's traditional AI and then there is generative AI. Traditional AIs often follow set procedures or logic paths. They process and understand existing information rather than creating anything new. And they process this information from patterns, underlying patterns in the data that they see. These outputs created by traditional AIs are usually specific answers or classifications or predictions within the scope, within that narrow scope. If you look at generative AI, they often create new contents such as texts, images, music, and a lot of other media types. They do learn underlying patterns, but then they also create their own patterns from learning and self-improving through feedback and additional training. You may already be able to see how traditional and generative AI are different from each other, but we can look at it from three different perspectives. When it comes to input processing, traditional AI relies on structured data with specific variables, whereas generative AI is fine dealing with massive data sets with a lot less structure. When it comes to learning, traditional AI only learns specific tasks and performs well in those tasks, whereas generative AI is working on a self-supervised loop and gets feedback and self-improves by learning on massive scales of data. When it comes to output generation, when you use traditional AI, you will usually get an output as a yes or no or a specific number, whereas generative AI creates new contents as outputs. When you ask it a question, it can provide you different answers in different iterations or something you may not even have considered before. Both traditional and generative AI have their own unique strengths and weaknesses. Traditional AI requires a lot less resources than generative AI. They are usually suitable for environments that have limited computing power. They produce consistent and predictable outputs, which is why it makes them a good choice for regulated industries like finance and healthcare. Because the decision paths can be traced and understood, they are quite good with even EU's transparency requirements. On the other hand, generative AI, because they generate new art, music, and design concepts, they can grasp concepts and nuances and intents, which traditional AIs can't do. They are quite good at tasks such as natural language understanding and pattern recognition. And they are good for generating ideas that traditional AI won't be able to do. Because both traditional AI and generative AI have their own strengths, the idea is to combine them. A hybrid approach using both by creating feedback loops to refine and improve both AI systems will yield a win-win solution. Traditional AI identifies patterns and insights, while Gen AI leverages those insights to create new solutions. Let's look at one of the use cases here. If you look at personalized marketing, using traditional AI, you can segment customers, you can do behavior analysis, whereas using generative AI, you can create creative and personalized customer ads, contents, and different offers. And as a result, what you can expect is much higher engagement, a lot more conversion of customers, and a bigger ROI. So the idea is that we should invest in both for creating a comprehensive AI strategy. Any discussion of AI is not going to be complete if we don't talk about the core AI technologies that power it. They are machine learning, deep learning, computer vision, and natural language processing. Machine learning is the broader umbrella, which is a system that learns from data without explicit programming, which really means it doesn't rely on explicit rules, but it learns to identify underlying patterns from the data. If you look at deep learning, it falls under machine learning, but it is a bit more specialized and it uses neural networks inspired by human brain to give you predictions or results or any output. Computer vision is another subfield of deep learning, which allows machines to see and interpret visual information. When you see things such as image generation algorithms, that is really computer vision. Now, natural language processing is probably one of the most used one at present, and all the generative AI models are based on natural language processing. It helps machines to understand human languages, so it can generate language and it tries to identify underlying patterns in text data. Many people think of AI as robots or complex future tech, but the reality is AI already surrounds us, making many everyday tasks easier and more personalized. This slide highlights just a few examples of how AI impacts our routines constantly. Think about using voice commands on your phone or smart speaker like Siri, Google Assistant, or Alexa. That's AI at work. Specifically, natural language processing, which tries to understand your speech and intends to answer your questions, set reminders, or control devices. When you browse Netflix or YouTube, the suggestions you get are powered by AI. Similarly, music streaming services like Spotify uses AI to curate personalized playlists like Discover Weekly or your Time Capsule based on what you listen to. When you use navigation apps like Google, AI is constantly working. It analyzes real-time traffic data, predicts travel times, and calculates the most efficient routes, rerouting you based on changing conditions.
So we've looked at how AI has been used in our day-to-day life, but let's look at some examples of how AI has been used for societal good. For healthcare, AI has been very useful for diagnosing diseases from medical images and for discovering new drugs. For transportation, the technology behind self-driving cars is driven by AI. If you think of an example for education, you have AI tutors these days that can provide 24/7 support, but you don't have to wait for a tutor's help when you need it. And AI is there to help you. For environment, if you think of climate models, that is AI powered and that can accurately predict weather patterns. And these are just a few examples, and there are numerous examples like that. AI presents both incredible opportunities and potential challenges. Understanding this duality is crucial for navigating its development and deployment responsibly. On a positive note, if we think about optimizing hospital operations, managing energy grids more effectively, streamlining logistics, or improving public transport, AI can make these vital services run much more efficiently. If we think of new solutions, AI offers a powerful tool to tackle huge global issues, such as accelerating scientific research for diseases, modeling climate change impacts, improving agricultural yields, or aiding in disaster response coordination. In terms of economic growth, AI has been a major driver of technological innovation, leading to new products, services, and even entire industries. This has the potential to boost productivity and stimulate significant economic growth. So the potential upside is enormous. However, we must balance this optimism with a clear view of the potential risks. One of them, and that is very much on top of everyone's mind at the moment, is job displacement. Automation driven by AI could displace workers in various sectors, requiring workforce adoption and new social safety nets. Then bias and discrimination is another one. AI systems can inherit and amplify biases present in their training data, leading to unfair discriminatory outcomes in areas like hiring, loan applications, or even policing. In terms of privacy, AI often relies on vast datasets, raising significant concerns about data privacy, surveillance, and the potential misuse of personal information. In terms of security threats, AI could be used maliciously, for example in creating more sophisticated cyber attacks, autonomous weapons, or spreading disinformation at scale. So the goal isn't about halting progress, but to proceed thoughtfully. Because the idea is to develop AI thoughtfully and not recklessly, we need to take a human-centric approach while developing AI. But what is human-centric AI? It is AI systems designed to serve human needs and uphold fundamental rights. It needs to prioritize people over technology. The core value of human-centric AI includes respect for human autonomy, protection of individual freedoms, and focus on social benefit. Which is why the objective of human-centric AI is to ensure technological advancement that will support humanity while preventing harm and exploitation of vulnerable groups. As AI becomes more capable and integrated into society, it is critical we ask how it impacts people. That's why a human-centric approach is essential. This isn't about making AI work, but making it work for people in a responsible and beneficial way. This slide breaks down key elements of this approach, structured like a pyramid to show how these concepts build on top of each other. At the bottom of this pyramid we have is inclusive design. It means proactively designing AI systems that are fair, equitable, and accessible to everyone, regardless of their background, abilities, or location. We need to consider diverse societies and ensure AI doesn't perpetuate or even worsen existing biases or inequalities. The goal is AI truly works for everyone. That brings us to the middle layer, which is safety and rights. Building upon inclusivity, we must prioritize safety and rights. As we rely more on the automated systems, we need to ensure they are safe and respect fundamental human rights. This includes protecting user privacy, ensuring data security, safeguarding human dignity, and preserving individual agency, meaning people retain control and aren't simply subjected to automated decisions without recourse. It's about building trustworthy systems that don't harm or disempower individuals. On the top of this pyramid, we have human values, which guides everything. This involves establishing strong ethical frameworks to govern AI development and deployment. The core idea is to ensure that AI ultimately serves humanity's best interests, promoting well-being, fairness, and positive outcomes. We need to align AI's objectives with our values to prevent misuse and ensure it contributes positively to our world. To ensure AI is developed responsibly and ethically, we need to embed core human values into the process. These human values aren't abstract ideas, they translate into concrete design and AI governance principles. First is transparency. We need AI systems where the decision-making process is understandable at least to some degree. This means moving away from black box models, especially in critical applications. Why? So we can debug systems, audit them for biases, build user trust, and understand why a particular outcome has occurred. Next is fairness. AI learns from data, and data can reflect historical biases. Fairness in AI means actively working to ensure that AI systems produce equitable outcomes and don't discriminate against different groups. This requires careful dataset selection, bias detection and mitigation strategies during development and deployment. The goal is that AI should treat individuals and groups justly. Equally vital is accountability. When an AI system makes a decision or takes an action, especially one with consequences, there must be clear lines of responsibility. Who's accountable if something goes wrong? We need frameworks to determine responsibility, whether it lies with the developers, deployers, or operators. This includes mechanisms for oversight, auditing, and providing redress when errors or harms occur. Last but not least is privacy. AI systems often rely on large amounts of data, which can be deeply personal. Respecting privacy is fundamental. This means protecting personal data, ensuring user consent and control, and implementing strong security measures. It's about safeguarding personal boundaries and preventing the misuse of sensitive information in an increasingly data-driven world. These four values, transparency, fairness, accountability, and privacy, are interconnected and essential pillars for building trustworthy AI. Embedding these principles into the entire AI life cycle, from design to deployment, is key to ensuring AI develops in a way that benefits society and respects human dignity. Now let's look at how EU has been leading the way in developing human-centric AI. The European Commission set out its initial strategy by emphasizing the need for AI to be developed and used in a way that respects fundamental rights and ethical principles in the beginning of 2018. It announced the creation of a high-level expert group on AI. And at the end of 2018, the Commission and Member States released a plan to foster AI development and use in Europe, framed within ethical guidelines and aiming to boost investment. Then on April 2019, the high-level expert group of AI published a landmark guidelines defining trustworthy AI based on EU fundamental rights and values. It outlined 7 key requirements for human-centric AI, some of the requirements being human agency and oversight, technical robustness and safety, privacy and data governance, transparency, so on and so forth. Then on April 2021, the European Commission proposed the first ever comprehensive legal framework for AI. This landmark proposal introduced a risk-based approach by classifying AI systems as unacceptable, high, limited, or minimal. In December 2023, the European Parliament and the Council reached a political agreement on the final text of the AI Act after negotiations, reinforcing safeguards for fundamental rights and adding rules for general-purpose AI. In March 2024, the Parliament formally adopted the agreed-upon text of the AI Act. Then on May 2024, the Council of the EU gave its final endorsement to the AI Act. Then in July 2024, the AI Act was formally published, and in August 2024, the regulation officially entered into force, starting the clock for its phased implementation, with most provisions set out to become effective from August to 2026. In February 2025, the ban on AI systems posing unacceptable risks took effect, and requirements for AI literacy also began to apply. In February 2025, the launch of Invest AI took place to mobilize £200 billion for AI investment. In March 2025, the publication of the third draft of the General Purpose AI Code of Practice, setting commitments to transparency, risk assessment, and mitigation for providers of general purpose AI models took place. Now we will go into a bit more detail on the EU AI Act. As we've seen in the previous slide, the Act takes a risk-based classification of AI systems by defining 4 risk categories for AI systems, each with specific regulatory requirements. The first one is unacceptable risk. AI systems that pose a clear threat to people's safety, livelihoods, or rights are strictly prohibited. Examples of such are social scoring, manipulative AI, certain types of biometric identification, and emotion recognition in sensitive contexts. Next is the high-risk ones. AI systems that are used in critical areas such as infrastructure, healthcare, education, employment, law enforcement, and access to essential services are considered high-risk AIs. These systems are allowed but subject to stringent obligations including risk management, transparency, human oversight, and conformity assessments. Next is limited risk. AI systems that may manipulate or deceive users, such as chatbots or generative AI, are such AIs. These require transparency measures, meaning users must be informed when they are interacting with AI or when content is artificially generated. At the bottom of the chain is minimal or no risk AI. These are the AI systems that pose no risk or little risk, such as spam, filters, or AI-enabled video games. These are largely unregulated. The providers are encouraged to follow voluntary codes of conduct. This four-tiered framework allows the EU to regulate AI proportionally by focusing the strictest rules on applications with the greatest potential for harm. Just like any other act, AI Act comes with its own unique challenges in application of it. One of the core challenges is finding a balance between fostering innovation and imposing necessary safeguards. Over-regulation could discourage research and development, especially for startups and smaller companies. On the other hand, under-regulation risks ethical lapses and public mistrust. Then, if we think of cross-border phenomena, AI is inherently cross-border systems and are developed in one region but deployed in another. Without international coordination, there is a risk of regulatory arbitrage where companies shift operations to less regulated jurisdictions. The AI Act must align with global standards to be both effective and fair. Next is technical implementation. Turning high-level legal principles into concrete technical rules is always complex. Developers need clear guidance on how to comply with requirements like transparency, explainability, or robustness. There is a risk that compliance burdens become too heavy, especially if tools for testing and certification are immature. The next one is market impact. The AI Act could reshape the competitive landscape, especially within the EU. But overly strict rules may disadvantage European AI companies compared to those operating in less regulated markets. On the positive side, a strong regulatory framework could build trust, making European AI more attractive globally and more trustworthy. Now, we have seen some examples of how AI has been benefiting individuals, but how responsible AI has been benefiting individuals. And these are some of the examples that you will see in your lives. AI adapts to needs of us by providing tailored recommendations and support by personalizing services. AI tools can also make technology accessible to people who have disabilities. Then when it comes to time savings, AI can handle routine tasks by freeing our time to do more creative and interesting work. Responsible AI isn't just about helping individuals or preventing individual harm. It also has the power to bring real positive change to our communities. First, it can enhance social cohesion by enabling more targeted community services. When resources are directed where they're most needed, neighborhood bonds grow stronger. Second, in times of crisis, AI plays a critical role in emergency response. It helps authorities coordinate faster and more effectively, whether during natural disasters, pandemics, or public safety incidents. Third, AI contributes to environmental protections. With the help of predictive models, we can improve conservation strategies, monitor pollution, and support climate action efforts more effectively. And finally, responsible AI expands educational access. Through adaptive learning platforms and remote education tools, it helps underserved populations access quality learning opportunities, no matter where they are. In short, responsible AI, when applied thoughtfully, can empower safer, more inclusive, and more sustainable communities.
Now let's look at how the EU has been leading the way in human-centric AI. Let's look at the example from Helsinki University Hospital from Finland. HUS's digital health strategy explicitly emphasizes patient-centered care, aiming to use AI to improve diagnosis, treatment, and patient experience. Here, AI tools are designed to augment clinician decision-making, not replace it, ensuring human oversight. Finland's healthcare system, including Helsinki University Hospital, operates under strict GDPR and national data protection regulations. Here, explicit patient consent is required for the use of AI tools that processes personal health data, and patients are informed about their use of search technologies in their care. Another example is of Barcelona. Here, AI is used to analyze urban data to improve city management and services. Citizen-controlled data commons are putting residents in charge of how urban data is collected and used. Barcelona is internationally recognized for pioneering a citizen-centric data governance model as part of its smart city strategy. The last example is of Estonia. Estonia is a global leader in digital identity. Here, AI helps monitor access logs and flag suspicious activity, supporting privacy and oversight. Citizens have the right to see who has accessed their data and can challenge unauthorized access. Like Finland, Estonia adheres to GDPR and has its own strict data protection laws. Public sector in Estonia are subject to regular audits and parliamentary review. Now, these are just a few examples. There are a lot of other examples in the EU. Now, let's look at what we can do to adopt AI responsibly and ethically. First, look at what companies can do. For any successful AI adoption, companies must focus on 4 critical pillars that work together to create both competitive advantage and responsible deployment. First is ethics by design. Build ethical considerations into your AI from day one and not as an afterthought. This will create customer trust and competitive advantage. Second, establish compliance frameworks with comprehensive documentation and processes throughout your AI lifecycle. This future-proofs you against evolving regulations. Third one is implementing technical solutions. Explainable AI algorithms and bias detection tools form part of this. Stakeholders need to understand how your AI makes decisions to be able to fully trust your system. Finally, building diverse teams. Varied perspectives catch blind spots and biases before they reach production, making your AI more effective and inclusive. These 4 pillars aren't optional, they are crucial. Companies that integrate ethics, compliance, technical rigor, and diversity don't just deploy AI, they deploy AI that drives sustainable business value while maintaining trust. Governments play a crucial role in shaping the AI landscape. Here are some essential steps for responsible AI adoption in the public sector. First is education and awareness. Governments must increase public understanding of AI capabilities and limitations while training professionals in ethical AI practices. Informed citizens will lead to better policymaking and increased trust in the policy. Second, multi-stakeholder governance. This means involving diverse voices in shaping AI policy, particularly ensuring representation from affected communities. Good governance requires input from those who will be impacted the most. Third is continuous evaluation. Governments must monitor regulation effectiveness and adopt frameworks as technologies emerge. AI evolves rapidly. Our oversight must evolve with it as well. Finally, international collaboration. Working across borders on shared standards while promoting European values globally is also a very important aspect of improving AI. AI challenges don't respect national boundaries, neither should our solutions. These 4 pillars create a foundation for AI governance that protects citizens while fostering innovation. Successful government AI adoption requires education, inclusive governance, adaptive oversight, and global cooperation. As AI becomes part of our lives, every citizen has a role to play in shaping its development. Here are some actions we can take to ensure AI serves everyone's interests. First, Ask critical questions. Challenge assumptions about what AI should optimize for. And don't just accept that faster or more efficient way is always better. Ask who benefits and who might be left behind. Secondly, advocate for inclusion. Ensure diverse voices influence AI development. When companies and governments make AI decisions, demand that people like you and people unlike you have a seat at the table. Third, demand transparency. Support systems that explain the decision making. When AI affects your life, from loan decisions to job applications, you have the right to understand how those decisions are made. Finally, stay informed. Follow emerging AI ethics frameworks and regulations. The landscape is changing rapidly, and informed citizens make better advocates for responsible AI. So remember, AI isn't inevitable, it is a choice. By questioning, advocating, demanding transparency, and staying informed, you'll help ensure AI development serves humanity's best interests, not just the interests of those building it. You're almost reaching the end of this presentation. So let's conclude this by talking about what the future may look like, some opportunities and challenges we face with AI. As AI develops, we stand at a crossroads. Our challenge isn't just developing smarter technology, it's ensuring that technology serves humanity. We must harness AI's potential while preserving human dignity. At the foundation of our AI future lies ethical AI, creating systems that reflect our human values. This means building AI that doesn't just optimize for efficiency, but considers fairness, transparency, and human welfare in every decision. Supporting this is regulation, which means developing frameworks for responsible innovation. We need smart governance that protects people without stifling progress, creating guardrails that guide AI development towards beneficial outcomes. The Broadcast Foundation is education, preparing society for an AI-integrated world. This means teaching technical literacy, critical thinking about AI systems, and fostering public dialogue about the future we want to create. These three pillars work together like a pyramid. Without ethical foundations, regulation lacks direction. Without regulation, education lacks context. Without education, society cannot meaningfully participate in shaping AI's future. The decisions we make today will determine whether AI becomes humanity's greatest tool or its greatest challenge. As we conclude this presentation, let me leave you with three key takeaways that should guide your approach to AI development and implementation. First, AI is transformative. Human-centric AI is reshaping entire industries while prioritizing ethical considerations. This isn't just about making processes faster. It's about fundamentally reimagining how we work, live, interact with technology in ways that put people first. Secondly, balance is essential. The most successful AI implementations don't choose between innovation and responsibility. They achieve both. We must advance technological capabilities while maintaining ethical standards and social responsibility. Third, the human element remains crucial. AI should enhance human capabilities, not replace human judgment. The handshake between human and AI represents partnership, not substitution. Our goal is augmentation, not automation of human decision making. The choice we make today in embracing these principles will determine whether AI becomes a tool for human flourishing or merely technological advancements. I thank you for your attention and for joining me in exploring these vital questions. Let's build an AI future that amplifies our best human qualities while addressing our greatest challenges together.